management in the data center, and stupidity cannot be mitigated by expecting people not to do stupid things. I just want to start by saying people aren't stupid, but the things we do sometimes are stupid. I've got an enormous list of stupid things I've done in my lifetime, and so it's not hard to imagine that if we just expect people not to do stupid things, it's not going to work well. So 70% of data center outages are caused from human error, as we've seen over and over and over again. If you look at the data center standards, we see all of them pointing to 70% of data center outage, and then immediately sort of like, but now we're going to talk about this other piece over here, which isn't data center, human error. To just look at a few things that human error impacts, more and more as data centers become more and more part of what we do every day. We look at the airline industry as a leading indication here, and in the last sort of 24 months alone, you've had almost 700,000 people stranded for some period of time because of a data center outage. It's cost the airline industry over $600 million, and that's just for the initial point in time where those errors actually occur. Now, we pick on the airline industry in this case because they're a great example of why we need to be more focused as good data center providers and good corporate providers, because these are starting to really impact human lives. There are a few very mature data center industries in the market around the world, aviation being one, nuclear power being another, petrochemical, medical industries. And those are easy to understand why they're so targeted, because when they have mistakes, they are massively impacting. They either destroy environments and ecosystems, or people die from one point to another. To date, I have not been able to find a specific case where someone died as the result of a data center outage who weren't part of the data center team. There have been people die on the job from electrocution or other events. But what we're really looking at in the aspect of impact is not the people running the DC as much as the end users being impacted from these data center outages. And with the leading cause being human error, it's a bit baffling why the data center industry looks at standards that are based on redundancy and availability, but they've reached as far as they can actually get. So one thing I want to mention here is that when we start this conversation about human error, what I see oftentimes is a message that we want to reduce those errors, error reduction is been the focus. And the few things that are in the industry at the moment around standards and some of the operational standards, if you look at them, they're not really focused on human error management. A few of them say that they are, and they're really not. They're actually more focused on the error reduction side, which is also where the majority of these design standards actually fall as well too. So the difference here is that with error management, we actually know that errors are going to occur. We know that we can never reduce them to zero. We can't reduce them to zero, especially with humans. It's just too difficult to to manage them down. And one of the points is that when we look at mechanical systems, we think about a chiller or a generator or an air conditioning system or a pump. They tend to be measured in tens to hundreds of thousands of hours before they fail. We call that an MTBF, mean time between failure. Does anybody have any idea what the MTBF for a human is? How frequently do we make a mistake? How frequently do we create errors? About every 4 minutes. Now, the issue though is that humans make lots of mistakes, but the mistakes that they make are generally quite, innocuous, right? Think about the number of times that you've dropped your pencil or your phone or, anything that you might happen to be holding. And then think about the context of, did I mean to drop this? There's a difference between doing that and then fumbling it, as you're trying to get something out of your pocket and it falls on the floor. So the errors that humans create and the frequency at which they create them gives so many opportunities for those to cascade into something that's more severe. And that's the problem that we have. When we have these mechanical components fail, it tends to be, in many cases, life-ending for that component. The data center design standards focus on the single component failure at the higher availability levels without actually impacting the overall system. It's why we build in that redundancy. But this is the other interesting point. Single component failures are not what cause data center outages. One component failing very, very, very rarely, unless you don't have any redundancy in your system, is not going to cause a wide-scale data center outage. So when we look at the design standards, we talk about the 70% being human error, so there's 30% that's something else. And this is another problem within the industry. There's this frequent view that the other 30% is mechanical failure. And I'll include electrical components as being mechanical. At the end of the day, they're just devices that give out over time as well too. But we actually have 3 other areas besides human error and mechanical failures that cause data center outages. So we have disasters, and I don't care whether it's a human-made disaster or a natural disaster, disasters are disasters. And disasters, strangely enough, can be disastrous. We have things from munitions plants exploding to welding, oxyacetylene torch plants exploding, big wildfires like we have in California at the moment, earthquakes that we get in Japan all the time, all those kinds of things, they're all disasters. Doesn't matter whether they're made by humans or not. The only time we care about that is if we put it in a known human disaster area, build it next to the munitions plant, that's probably a bad site selection choice. We could argue that that was a human error, but most of the time disasters are just disasters. Sabotage is another one. We don't see it horrendously often, but it is there, and it's kind of the opposite of human error. It's human intention. So we don't call those human errors. And then the last one is a very little known area, which I made this term up because I couldn't find anything else in the industry that matches it, called true accident. So I only have one example in over 15 years of looking at this stuff as a true accident. But a true accident in general means this is a third party entirely outside the data center, either operation or even user side. It's something completely random. And the one example of this I have was a data center I was working with in the Middle East. It was built at a time in a location where everything was fine, but then a conflict broke out. In the middle of that conflict, not too far away, somebody fired a tank round at a target and they missed. And it went through the back corner of the data center and took 2 racks of the data center in the back of the data center out. So this is not human error because it wasn't, it's not sabotage because they weren't targeting it. It's not human error because it has nothing to do with the data center. And we genuinely have just a stray tank round going through. Now, the fact that I can't come up with more of them at the moment isn't actually the point here. The fact that we can come up with one means there's a percentage of this that actually does encounter the rest of this 30%. So the issue that I have with the design standards as a whole, when they say 70% is this, and then they try to turn around and say we're focusing the other 30%, they're really not. Some are doing more, some are doing less, but at the most they're really only accounting for about another 20% of that 30%. So those things are also things that can impact our outage issues. So human errors come in different sizes and shapes as well too. As I mentioned at the start, I started to talk about one that we classify as involuntary. Involuntary comes in lots of ways as well too. A muscle twitch, a sneeze, somebody slams the door and it startles us. All those things are involuntary reactions. We fumble a phone, we drop something on the floor. We also have decision errors, which is, people just make a bad decision. Skill errors is one that accounts for the largest amount of human error. So skill, this is where the training side comes in, but also why training alone can't reduce your error rates entirely, right? They reduce your errors for skill errors, but it really doesn't, training really doesn't address much of the rest of these. A little bit in the decision side when we look at how we make good decisions. Errors in attitude, and this is different from perception errors or skill errors, where there are times where people just don't care. I just don't care. Really poor attitudes about what you're doing. I'm here, I hate this company, I get a paycheck, I go home, means I might even see some of these things and I just don't do anything about them. Impairment errors include things like, actual physical limitations. I try to pick up something heavier than I can actually physically lift is actually an impairment error. I am too tired, I'm too stressed, I have too much distraction taking place. So those impairments are all part of, distractions are all part of the impairment errors. It can also mean medical or medication, not intentional, and it can also mean substance abuse or alcohol abuse. Any of these things that limit our ability to react are things that are created by impairments. Now, one of the interesting things is I picked this image to put here. Anybody know what this is? Has anybody seen this? This is the Samsung data center fire from 2014, which happened in Seoul. And the fire took place, started on the roof with a generator. I can't tell you, I know exactly what happened here, but I'm not allowed to give you all the details of it. But essentially, what happened was the data center was being upgraded for some power and a number of other areas. Someone made a decision to run the generators because it was going to be more reliable than utility. So that was a perception error straight away, because it led to this happening. The other thing that was interesting is there were 9 generators on this rooftop, and they all were in 2-hour fire-rated containers. But the first one, the leading generator, caught fire. Here's the funny thing about those fire ratings that they don't seem to tell you, or they don't seem to focus on. Those ratings are for keeping a fire out, not from keeping a fire from getting out. And generators tend to be really freaking hot as well too, especially when things go wrong. So what happened in this case, each one of these 9 generators had a 1,000-liter service tank at the in their enclosure. When this gen caught fire, within 20 minutes, it had burned through the service tank. And so now we're literally pouring gasoline on a fire. Well, actually it was diesel fuel, but we're literally pouring fuel right on a fire. So on top of it not being rated for a fire inside, only outside, within 20 minutes it had burned through the compartment. And now you have this 1,000 liters of fuel spilling onto the ground, which the drain was that way, so it just started moving right along with the drain. It's a funny thing when fuel that's on fire starts moving down the rooftop, it tends to catch everything else on fire as well too. So that fire cascaded to the next generator. And enough heat because of what they had there, less than 2 hours, the fuel lines coming in, burned, boom. I faded this picture out so you can't quite see it, but you can see the whole front side of this. So this fire started here and worked its way this way, but you can see the entire face of this building is gone as well. That's because the main fuel supply was down here at ground level somewhere. And so when this tank burst open, it's like, ooh, I need fuel. So these tanks just continued to pump more and more and more fuel up the, up the side of the building, and then it started running back down the lines and cut the entire inside of this building. This was a 9-story data center that in 5.5 hours was completely destroyed. You'll notice the big helicopter water bomb up at the top. They needed to bring that in order to bring this data center fire under control. So when we actually look at that, the number of errors involved here, we compare them back to these various types. Within the span of about 10 minutes, we can find 8 or 10 different instances of errors made in the process of this. This is what causes disasters in data centers. This is what causes massive outages. Now the funny thing is, in our data on this one, we had to decide where to cut it off because this data center never reopened. They had to knock it down, and I don't know if they built another one there or not, but this DC never reopened. So it has an infinite amount of time of downtime after the event. So we decided to cut it off in our stats at 24 hours because that's how long it was before Samsung could actually get the services that this building were providing back up and running again. And this is another really critical part. A lot of people seem to miss this in that when it's not a matter of if you have a data center outage, it's when. You let it run long enough, you are going to have some level of outage in the data center. That may only be a single rack, it may be an entire DC. But give it enough time, it's going to happen. The more critical piece about this then becomes how fast can you recover? If you saw the British Airways outage a few months ago, about 2 months ago, it was a power issue. We don't know the whole story behind it. There's some talk about somebody switching something off, so there's lots of human errors potential in there. But the issue was it took them 2 days to get the center back up again. And then there was this whole knock-on effect. Our cost in this, about the cost that they spent on that or that they lost on that, was only about the 2-day recovery, not about the rest of it. I don't know how familiar you guys are with a study by a group called Payton. They did a study in 2010, and 2013, and 2016. And each year they publish a consolidated cost per outage. And so the cost in 2010 was $5,900 per minute. In 2016, it's gone up to $8,851 per minute. So, and that's an average. That doesn't take into account things like peak times as well. It doesn't take into account industries like the finance industry, where we have one client where they put about $11 million per minute through their system. So if they have an hour of downtime, it's huge. They do over $11 trillion of transaction per year. And it's a 24-hour operation. It never stops. So other influences in error, though, that make this difficult as well, is we also have things like the complexity of the system. So if we really look at the stats of human error, statistically it'll show you, we've said 70% in the data center, but the reality is it's between 40% and 82%. Now, I'll give you an example of that one, right? I was recently reading a book on brain surgery. And I think I've really got it. I thought it was, I completely understand it. So I wonder if I have any volunteers for just a little operation, just a test that I want to do, right? Because, come on, I only make a mistake at worst every 4 minutes. It'll only be 3 minutes. The complexity of that, though, is so profound that if you don't have the training in it, you're virtually 100% guaranteed to fail. So complexity plays an enormous role in this. The unknown, which is kind of complexity infinity. We don't know what we don't know. Those systems tend to be things where we get into trial and error. And look at that, we actually call that trial and error. We're basically almost certain to make mistakes during that period of time. So we need to encapsulate that. Time pressure is another thing that causes errors a lot, right? You are used to doing something in a certain period of time, you've got a process down, even though you could push faster, you keep it consistent so that you know that things, your checks and balances happen and you don't rush it. Well, somebody comes along and says, you've got half the time to do that you normally do that in right now. And so they put you under tremendous time pressure, kind of like my clock down here. Those pressures, the complexities, we don't know what we don't know, all of those things increase the probability that we can have an error. So when we look at what do we do about this, we have to really acknowledge that these things play significant roles in the process. The other thing about errors is when we make an error, it's usually while we were actually trying to do something else. And the problem then becomes we still needed to get whatever it was we were doing done. And now we have to deal with this error. And we might even be a little bit panicked because we might actually go, oh, that was a big mistake and I know I shouldn't have done that. So now I want to cover up for the mistake that I just made and I don't want anybody to know that. So we actually start trying to fix the error. Ask UBS about this. This is how the guy wound up spending like $5 billion of the company money because he kept trying to cover his error, cover his error, cover his error. It wasn't a data center error, but it was, it was an error. So what happens is then we cascade, right? When we have the big outages, so we have these cascading series of effects. So we start trying to fix the error, and then we make another error, and then another one. And now we're suddenly completely overloaded. So we hit what we call cognitive overload. We still need to do what we needed to do, and now we're trying to cover for all these mistakes that we just made. Completely wipes people out. So I think I mentioned a little bit about this before. The reason we have so many human errors is because we make those mistakes more frequently than our, inanimate counterparts. But I do get people that say this to me all the time. Well, why don't we just automate everything? Wouldn't automation solve all this problem? So I have 2 questions for that. Who makes the automation? Humans do. Who maintains the system that the automation is running in? Humans do. So this is about the error reduction side. We may bring the number of errors down, but it doesn't change the the percentage that we wind up occurring still. So there's two pieces of this part of the equation. It's a bit weird. If we have 1,000 outages, 700 of them would be human error and 30 would be non-human error. If we have 10 outages, 7 will be human error and 3 will be non-human error. So it becomes quite odd that maintains that that ratio throughout. But the reason is humans create far more opportunities for an error to occur than one of these other failures or disasters or sabotages actually occur. So it remains consistent throughout that time. So now we come down to the big piece about, so what can the data center industry do? What do we need to be doing in the data center industry that we're not doing today? Well, first, we need to share this outage information. One of the problems that we have with data center outages is that they're very secretive about them. Like I said, BA, we don't know what actually happened there. There's something about blaming CBRE for turning the switch off, and then that's all the data we ever got out of it, right? The same thing with the Samsung fire. I happen to be close to what actually happened there, so I know, but officially they said, yeah, something caught fire, and we had to spend hours putting it out. That was all that was ever mentioned about it. Next thing we need to do is the data center industry needs to start taking this really seriously and self-regulate, or you're going to get regulated. And I got to tell you, the picture of getting regulated by somebody else is going to be ugly. So this is one of the most important things. We need to start showing that we're actually making error management progress and creating these strategies to prevent these errors from cascading into serious outages. Or the governments are going to step in. I can guarantee you the first time you find a death that's directly related to a data center outage, that's what's going to happen. And it's only a matter of time. We need to create a framework that we can use to build how these strategies are done, how they're implemented, because the other thing is we don't want to just knee-jerk our way into this. If we see a problem, we go, well, there's a solution for it. If we don't test that against criteria for intervention strategies, we could actually wind up making things worse. And lastly, at this stage, we need to have a bigger focus on an error management culture. So again, the management here is the gap between the error occurring and it being allowed to cascade into something serious. That's the piece we have to actually put together. And I'm out of time. I don't know if we have time for a question or not, or if there are.
In the last slide, you showed a footnote which says that 80% of outages are UPS related.
Yes.
Now, is this referring to the technology, the equipment failure, or it's manual failure?
So here's the thing actually very quickly. The reality of why UPSs are responsible for 80% of outages is they are the most closely coupled electrical component to the IT load. So you do anything wrong there and IT load is lost. Whereas if you screw up your utility side, your generators kick in, or your generator isn't working, then your UPS can carry the load. But if you drop the load of the UPS, you're dead.
Yeah, so that's the last mile kind of a thing.
Now it's not last mile, it's the first line and last line of defense, whether you're going this way or that way. So that's the problem. That and the fact that a mistake happens so easily. This is one of the most complex areas of data centers. And you make one mistake in that, even trying to move to utility bypass, for those of you who don't know, series of about 20 to 40 steps depending upon your implementation. You change one breaker in the wrong order and the whole thing comes down. Because you've either opened something too soon or you closed something too early, which causes the rest of them to automatically pop because you're now shorting the system. Thank you. That's why 80% today. So this is the low-hanging fruit of the two pieces, right? Focus on human error management around your UPSs first, and then we can work our way back out from there. Okay, I think in the interest of time and respect for the next group coming in, we probably have to cut this off. So thanks very much for your questions, and thanks for attending. Our booth is B42. Please come around and have a chat with us.